So what is a stick diagram? What's the aim of it? Already have mentioned. So we have to translate the circuit onto silicon. That is our requirement, right? We have to translate the circuit to silicon. That's what VLSI fabrication is in brief, right? So stick diagrams are nothing but they for the layer information. If you want to represent the layer information with simple diagrams, we go for stick diagram. Okay, the layer information. So stick diagrams for generally can be having monochrome encoding we can have, but the stick diagrams will have the color codes. Stick diagrams will have the color codes, and there will be the interface between the layout and the circuit. Okay, there will be interface between the layout and the circuit. That's what I mentioned. From the circuit, we have to develop a layout, and from the layout, we will give the GDS2, we will develop the GDS2 file, which will be given as an input for the fab to develop the mask. So we, as it is a little bit complex to directly convert the circuit into a layout, the stick diagrams will act as the interface. Okay, so what are the features of stick diagrams? They will not show the vias. So vias means, say if you have two different layers, okay, we cannot directly connect two different layers. We have to use a via. Okay, so generally they will not show the vias, and they will show only relative placement. They will not show exact placement. Okay, so they will not show exact dimension also. They will not do exact dimension also. So they will not show exact placement, exact transistor sizes. They will not show exact wire lengths, wire widths. Okay, so only what they will do is just they will give us an idea of the layout. So now how to draw stick diagrams? Okay, further stick diagram will have a color code. Okay, you please remember these color codes. This is very, very important. Whenever we want to draw a stick diagram, we have to use these color codes. Okay, so say P diffusion yellow, N diffusion green, polysilicon red, metal blue. So I think you can easily remember these colors, right? Hello. P diffusion yellow, N diffusion green, polysilicon red, metal blue. These are the important layers, right? So sometimes if you do not have the color diagrams, we can have monochrome with black and white with the different hatchings. See, say this is polysilicon is a continuous line, P diffusion and N diffusion and metal. We can have different, say black and white, different hatchings like this dashed lines we can use with different topography. Hello. So I request all of you, please concentrate. This is very, very important. You have more marks weightage for developing stick diagrams and layout diagrams. Can I go further? Hello.
Yes, ma'am.
The others, are you there in the class, or I hope you are awake?
Yes, ma'am.
Yes, ma'am.
Yeah, please concentrate. Okay. You can remember this color coding, right? Now,
Yes, ma'am.
how to draw? In drawing stick diagrams, we should remember some rules. When two or more sticks of same type cross each other, that represents an electrical contact. For example, two blue sticks, say they cross each other, same type, it's a contact. Obviously it is a contact. Obviously it is a contact. So if you do not want contact between two different metal layers, we should see that they should not cross each other. Okay, if the colors of the same type touch each other, it is a connection. Okay, and if sticks of different colors touch each other, there is no contact. We have to understand that there is no contact. Are you getting my point? Hello? And for example, if two different colors touch, if you want connection between this reddish polysilicon, this bluish metal, here they touch each other. That means there are two different layers. There is no connection at all. Okay. But if you want connection between them, you have to provide a electrical contact. Are you getting my point? Hello?
Yes, ma'am.
Whereas here, both blue, if they just touch, it's a contact. Both polysilicon, if they touch, that is a contact. And other most important thing is, whenever a poly crosses diffusion, polysilicon area crosses either P diffusion or N diffusion, it represents a transistor. Please remember this very, very, very well. A green crosses red means green is N diffusion. It's crossing polysilicon means it forms a transistor. Because you remember your N MOSFET architecture, N diffusion, over that silicon dioxide, over that polysilicon metal, polysilicon acts as a gate, right? So metal, conducting layer. So polysilicon gate. If you observe, gate is a polysilicon, N diffusion is source and drain. Silicon dioxide layer is everywhere. So we will not represent the insulation layer in the stick diagram. Whenever we have two different layers, understand that there is a silicon dioxide in between those two layers, right? So whenever green diffusion crosses polysilicon means you have to understand that this is source, this is drain, and this is gate. Similarly, P diffusion and polysilicon, source, drain, and gate. You have to understand that it is a transistor. But where if you provide an electrical contact between N diffusion and polysilicon or P diffusion and polysilicon, it is not a transistor. If you provide an electrical contact, because we know that the gate and the source and drain are isolated by silicon dioxide, gate oxide, then only it is a FET, right? But if there is an electrical contact like this, it is not a transistor. Are you getting my point? Hello.
Yes, ma'am.
And then what's the next rule is, so we should have a demarcation line which is in brown color, dash, say dash dot dash dot, or we can say so it's a demarcation line. This demarcation line is used to separate the PMOS circuit and the NMOS circuit. See, this is, so see here, this is yellow crossing red. What is yellow crossing red? What it represents in stick diagram? Yellow crossing red. What it represents in stick diagram? P diffusion crossing polysilicon is P MOSFET. Green crossing red. N diffusion crossing polysilicon is N MOSFET. Okay. So this is PMOS circuit and this is NMOS circuit. We should have a demarcation line, brown color demarcation line, which separates NMOSFET and PMOSFET. So PMOS should lie on one side of the demarcation line and NMOS should lie on the other side of the demarcation line. Are you getting it? Please don't read the slides. Listen to me. Okay. Hello. Later, as I'm uploading these slides, you can read the slides later. Hello.
Yes, ma'am.
Okay, now how to draw the stick diagrams. Okay. First of all, I'll show you the basic, very basic stick diagrams, and then we'll go with the complicated stick diagrams. I request all of you, please concentrate. Okay. So initially, let us take an inverter. Okay. So first we start the stick diagram, like how we draw the circuit. Okay. So generally to draw the circuit, we have a supply line and ground line, or VDD line and VSS line, correct? So the supply line should be metallic, right? So the connection should be in metal. So we have a metal layer for VDD and ground, or VDD and VSS. First draw two metal layers. Okay. Then we are drawing demarcation line. We are drawing demarcation line. Then this is the area for PMOS. This is the area for NMOS. Okay. And then you draw yellow stick here and green stick here. Yellow stick, green stick. Okay. Then see, here you should have a contact for the supply to PMOS, P diffusion, ground to N diffusion. So provide electrical contact. The black color solid dot is symbol for electrical contact cut. So whenever we provide a contact cut means after metallization, that will provide a contact to the component. Already have explained you, right? So This black dot represents contact cut. So if you provide a contact cut here means it is providing electrical connection. Okay. Got it?
Yes, ma'am.
Yes.
Then comes the polysilicon. So now P diffusion is crossing poly PMOS. N diffusion crossing poly NMOS. Then we we join these two drains. Then we provide electrical contacts. Then we just join this and we give input here. We just join this here, we give output. So this is the stick diagram for CMOS inverter. Same stick we can draw like this also. Technically there is no difference between these two. But only thing is here, the polysilicon is having, it is a shape like this, but here we give polysilicon straight. Okay. Then we have a bend in the P diffusion. But P diffusion crossing poly is a transistor PMOS. This is NMOS, electrical contact between metal and PMOS, between metal and NMOS. Then connections between two drains through metal contact. This is the output and this is the polysilicon input. So technically only it's a different representation, but technically there's no difference between these two stick diagrams. Both represent CMOS inverter. Any doubt here? Please tell me.
No, ma'am.
Okay. So this is a very simple way of developing a stick diagram. If you see this stick diagram almost resembles our circuit, right? Is it not like our circuit exactly? How do we draw CMOS inverter? So we have a PMOS, we have a NMOS. This is connected to ground. This is connected to supply. We are having the output here. We are having the input here. So almost it is resembling the circuit. Okay. Then, for example, this is a NOR gate, right? It is a NOR gate. We know this gate. Then, so see here, this is the stick diagram for a 2-input NOR gate. 2-input NOR gate. So, how he has drawn it, just I will show you. See, so why there are, if you observe this, you can understand what is a defect or difficulty in drawing these type of things. So do you understand this stick diagram, how they have drawn it? Hello, it's for 2-input NOR gate. So for a 2-in, how to draw the stick diagram? First draw metal lines, right? Please respond. Then
Yes,
we
ma'am.
have to draw demarcation line, right? So we have to draw demarcation line. Okay, just I'm using black for demarcation line. Okay, there is a demarcation line. After that, they have PMOS in series and NMOS in parallel. So what they are doing is they are drawing PMOS stick like this. Okay, and NMOS in parallel. So they are drawing NMOS stick like this. NMOS stick like this. And they are providing electrical contact here. They are providing electrical contact here. They are providing electrical contact here. Okay. And here, but here it's a 2-input NOR gate, right? So whenever it is a 2-input NOR gate, so we have 2 P diffusions here, right? So 2 P MOSFET like this I'm drawing. And this is here also I'm drawing like this. Are you getting my point? Hello? So
Yes, ma'am.
here, say for example, if this is A, this is A, this is B, this is B. So up to this it is okay. Now after this we have to provide the connections, right? So if we just draw A and A, we understand that it is a connection, but in the real circuit, connection must be established. Yes or no? In the circuit, we can say if you just write A and A, it will be, it is already, please take it granted that it is connected. But in the real layout, in the real fabrication, we have to provide contact. Must, it's a must. Yes or no? Hello? Are you getting my point? Hello?
Yes, ma'am.
So,
Yes, ma'am.
how it should be, for example, here, this is A. So I have to provide from here to here, I have to provide a contact. So this is A and A, right? And after this, say for example, if I have to provide again contact between B and B, see here. So this is A and A they made. Say for example, this is B and B directly they made. What is the next contact we have to make? See, already I made A and A. Next, what I have to make? B and B, correct? Are you getting my point? Hello? Hello?
Yes, ma'am.
So when I'm making B and B, I should not cross this green, correct? Hello? Because if I cross this green, what happens? It makes another transistor. So it's an error, correct? Hello?
Yes, ma'am.
And so I cannot cross this. And if I want to come like this also, I cannot cross this transistor. Okay. So what I have to do, I have to use a different, say I can use metal here. I can use metal here. And after that, I can continue this red color. Do you understand this? So this metal, if I am connecting means directly, I cannot use this metal because two different layers. Again, I need a connection here. Do you understand? I need a connection here. I need a connection here. Are you getting my point? So I need extra metal layer and two electrical contacts. So likewise, after this, I have to provide electrical connection, right? So in providing electrical connection, say this is blue and this is blue here. So this is the regular connection. So here I need an extra electrical contact and layer. If you see here, see, this is an additional. Are you getting my point? And this is also additional. See here. So this is additional and this is also additional. So if it is like this for just 2-input NOR gate, think about a complicated layout. So we have to provide many, we call them as vias, because here we cannot directly run polysilicon like this because there are different layers. So that's why what we have done, we have used, these are the two vias we can say. We have used a metal. So this metal layer and these two contacts, this metal layer and these two contacts are nothing but extra. Yes or no? Hello? Do you understand what I'm saying? So they are adding, whenever we have a contact, it adds resistance and capacitance to the circuit. Yes or no? I cannot go further if you do
Yes,
not
ma'am.
respond. Please, please, please. Do you understand the
Yes, ma'am.
complexity of what I'm saying?
Yes, ma'am.
Yes, ma'am.
Just imagine if it is a 4-input NOR gate, how the situation will be. We need more and more unnecessary contact gates, which adds more resistance and capacitance to the layout, right?
Yes, ma'am.
So we will not follow this, just the obvious method of stick diagram from the circuit. Okay, so we will use a different, little bit different approach. So that different approach is, say, it is just nothing but reversing. So far what we are doing here, so see here, we are writing this P diffusion and N diffusion vertical. polysilicon horizontal, because this is the general way we draw the circuit. General way we draw the circuit. So similarly, you see A plus B plus C. Okay, A into B plus C. See here. See this circuit. Okay. What the approach they have used, little bit what they have done is they have done A from this side, means they have used C from this side and they have used B from this side. Little bit change they have made. Okay, but still if it is complicated, we should have the more number of contact cuts. So they are using different approach. The different approaches, they made diffusion layers horizontal, polysilicon layers vertical. So see this is also an inverter. So why they are doing this? To avoid unnecessary electrical contacts. See this, you can understand this is an inverter, right? They made P diffusion horizontal, N diffusion also horizontal, polysilicon is vertical. Then they need connection from supply to P diffusion. Again, N diffusion to ground. They are making the electrical contact. And see here, this is a 3-input NAND gate. See here, it is they are using P diffusion horizontal, N diffusion horizontal, A, B, C polysilicon straight. So here they are not using any additional electrical contacts or vias, just like our previous example. So this example. You got my point? Hello.
Yes, ma'am.
Yes, ma'am.
So the present, what the stick diagrams, what we draw, we will follow this method. Okay. P diffusion and N diffusion horizontal, polysilicon vertical. Then this will give you the stick diagram without additional contacts and without some clumsiness also. See here, this circuit is more clumsy, right? So, but here this is very easily understandable circuit. So this method we follow. So can you understand this 3-input NAND gate? See here. So 3-input NAND gate, just series. So series means only the last NMOS will have the ground connection. The first NMOS will have the output connection. So these are the parallel things. This is how we draw the stick diagram. Okay. But still, when the expression is more and more complicated, there should be a scientific way of drawing the stick diagram. Just by looking into the circuit, if you draw a stick diagram, it may be, sometimes it may be having an error. So we should have a scientific way of developing the stick diagram. So we will try to develop the stick diagrams by using Euler's path. Are you getting my point? So I will tell you how to draw the stick diagram using Euler's path. Please understand it and try to get the idea. Okay. So this is an example of 3-input NOR gate and 3-input NAND gate. Okay. Actually speaking, these are also drawn by using Euler's path only. So I'll explain you what is Euler's path and how to draw stick diagram using Euler's path. So we'll draw many examples also so that it will be clear for you. Okay. So what is a Euler path actually? How stick diagram through Euler's path? What is a Euler path? Euler path is defined by tracing a path through a circuit, tracing a path through a circuit so that it traverses each transistor only once. Please remember this. What is a Euler path? It is nothing but tracing a path through a circuit. Tracing a path through a circuit such that each transistor is traversed only once. And in the Euler's path, the order of transistors has to be same for both PMOS and NMOS. Whatever the order of transistors in the NMOS circuit, we should follow the same order in the PMOS circuit. And Euler paths are not unique. For a given expression and for a given circuit, we can have more than one Euler path. So you can use any one of the Euler path. It doesn't matter. Are you getting my point? Hello? Hello.
Yes, ma'am.
So now I'll tell you how we can develop a stick diagram using Euler path. Please concentrate. Okay. Let us take one expression. I'm going with some little bit complicated expression so that you can draw the simple expressions very easily. Y equal to AB plus CD plus E whole bar. Okay, AB plus CD plus E whole bar. Immediately, whenever we want to draw the stick diagram, we should draw the circuit first, right? So all of you know how to draw this circuit, correct? Hello. AB plus CD plus E. This is the NMOS part. Then the corresponding PMOS part. Is the circuit correct? Hello.
Yes, ma'am.
So we should develop, we should see what is a Euler path for this circuit. And from once we know the Euler path, we will see how we can develop stick diagram using Euler path. What is a Euler path? It is nothing but traversing a circuit, okay, such that each transistor is traversed only once, developing a path through a circuit. For that, what we have to do is, first of all, we have to develop the equivalent graph for the circuit. Are you getting my point? We have to draw equivalent graph for the circuit. Okay, fine. So just see this. I'm making a graph for it. So this is a parallel circuit. Each node I'm naming uniquely. This is V. And here I'm getting node A and this is B. Okay. And here I'm naming this as say 1, node 1. Then I have again, this is C and D. I'm just calling this as 2. Then I have only one vertex and this is E. Okay. So here, this node, I'm calling it as Y. Then again, I have these two. Then I have these two. Then I have this. And this node is G. Please don't change these names, okay? So this is VDD, make it V, okay? And Y, make it Y. G, ground, make it G, okay? Remaining nodes, additional nodes, you can name them as either, I may named them as 1 and 2, you can make them as X and Y. So here also I can have 1 now. So this is A and this is B. Here I can have 3. This is C. This is D. Here I can have 4 and this is E. So this is the corresponding graph. Got it? Hello? Hello?
Yes, ma'am.
Now, let us find out the Euler path. Okay. Say, let us see. For example, if I start from A, C, E, PMOS circuit, I'm first finding. A, C, E. Then to traverse D and B, again, I should go through E only, correct? Yes. If I come like A, C, E. Again, I have to traverse E only for go to D and B. So I cannot start with E. For example, if I start with B, A, C, E. I cannot. So if I start with E, C, A, B, D, I can complete, right? If I start with E, C, A, B, D. Do you understand? Hello.
Yes, ma'am.
So if I start from A, AC, say A, C, E. Again, I have to go through E only because I have only one path here. Okay, so I cannot do that because Euler's path says I have to traverse only once. Okay, so I have to start with from E. If I start from E, E, C, A, B, D. So what is the path? E, C, A, B, D is my PMOS path. Let us see that path is available for me in NMOS or not. So let us see. This is E. For example, if I'm going for E, C, D, B, A, if you see here. Say what is the path I got? E, C, A, B, D. E, C, A, B, D. That's a path I got. So whether I will get this path here, E, C, D, B, A. Whether I get it here? Here I got E, C, A, B, D. E, C, A, B, D. Whether I will get it here? Please tell me.
Oh, ma'am, it's different.
I will never get it, right? Yes or no?
Yes, ma'am.
So we will not get Euler path from this. So what we have to do is we have to reshuffle the circuit. We have to redraw the circuit. Okay. So here from this circuit, we cannot find Euler path. We cannot find Euler path. So what I will do is just I will redraw the circuit. Same circuit, just I will redraw. How do I draw it? Just I'll do like this. You tell me, will it change my expression if I draw like this?
No, ma'am.
No,
No.
ma'am.
So that's why I'm just drawing like this. Okay. So this is my same circuit. I have redrawn it. Now let us take some path. Okay. I'm starting from here. Let us say I can draw like this. BAE. Okay. CD. I'm drawing BAECD. Okay. BAECD. Let us see whether that will be possible here or not. Okay. BAE. Here BAE. CD is not possible, right? So BAE DC. See? BAE DC. Whether BAE DC possible here or not? See?
Yes, ma'am, it's possible.
It's possible. So what I can do? What I'm doing is check. BAE DC. BAE DC I'm taking. BAE DC. Okay. So here also for me BAE DC is possible. So what is my Euler path here? BAE DC. Got it? Hello. Hello. So here I didn't draw the graph here, no? So I will draw the graph here because drawing graph is important for us to draw the stick diagram. So BAE DC is our path. Just I can show you by drawing the graph also. Okay. So I'm starting with node V, right? So I have A, B, I have node 1, then I have E, I have node 2, okay, then I have C, D, right? Then I have node Y. So what is my path here? What is my path? B, A, E, D, C. B, A, E, D, C. This is my PMOS part. Similarly, my NMOS part. What is my NMOS part? So I think I can draw here itself. Okay, I'm starting from Y. So my NMOS part is Y node. Then I have.
Ma'am, B you have given reverse arrow.
Yeah, okay, I'll check it. Yeah, it's correct. Okay, BAEDC. You can understand here, right? So see this path here. Okay, you understand, right? BAEDC. Yes, it is BAEDC. So here I can have A here and B here. No, here B. Okay, here I have E. Then I have E. Then I have CD, right? CD. So here I can have one more node 3. Here I can have node 4. Again, what is my path? B, A, E, D, C. B, A, E, D, C. Okay. Now let us draw the stick diagram from the Euler path. Actually, that's the most important thing, right? So all of you please be attentive. So what we have to do is, first of all, you draw VDD. Okay. And you draw ground. Okay. Then you draw yellow stick. Okay. Draw green stick. Okay. Then how many inputs are there? How many inputs are there? Hello. How many inputs we have?
Five.
5 inputs. Actually, why we need Euler path is this order is very, very important. B, A, E, D, C is our Euler path. So you take 5 inputs. 1, 2, 3, 4, 5. And give names B, A, E, D, C. This is the most important thing. B, A, E, D, C. After that, see the graph. See the graph. And translate the nodes from the graph to your stick. Node V. Where is node V? At only one place. Where is node V? At the junction of A and B, correct? Hello? Where is node V? At the junction of A and B, yes or no? So here. Okay. Are you getting my point? This area is junction of A and B. It's a combination of A and B. Next, where is node 1? Where is node 1? Node 1 is also at the junction of A and B. Hello. And also
Yes, ma'am.
It has to be joined with E also. It has to be joined with E also. Are you getting my point? V should be at A and B. And 1 is at combination of A and B and E. So here, what can we have here? Node 1 will be at combination of A, B and E. So where can I place it? Say, I can say at A, E, I can place 1, correct? I can place 1 at A and E, yes or no? Hello? Please understand. At combination of A and E is 1, right? Hello?
Yes, ma'am.
Yes, ma'am.
Similarly, what I can do is at B also, here also I will put 1. So what happens now? If I join these two through a metal, A, E, B will be joined. Yes or no? Hello.
Yes, ma'am.
Please respond. Please respond. If A, E, B, see here, A, E, this is a E and this is B. I gave 1. That means A, E, B, I gave only single node, correct?
Yes, ma'am.
Then please try to understand. Let me, if I complete, you will understand it clearly. Then where is it 2? 2 is at the combination of E, C, D. Y is only at CD. Y is only at CD. So this is CD combination. So I can place Y here. Okay, I can place Y here. And what is 2? ECD. So ED I can place 2. C also I can place 2. Okay. Then what I have to do is, see, V. V means supply, right? So this I'm joining with supply. Okay. Then 1, 2 ones I will join. 2 twos I will join. Okay. Here what I will do is I can join 2 twos like this. You can understand why I have joined like this. 2 twos I will join like this. So whenever, don't think that it is an arrow, okay? It is a V. This is V. So whenever metal joins with P diffusion, I have a contact cut, either a dot or cross. Doesn't matter. Dot or cross doesn't matter. Now you see this. Is it connected according to graph or not? Now check it. AB connected to supply. AEB connected at node 1. CD connected to output. And DEC connected at node 2. Are you getting it? Hello? Any doubt here?
Yes, ma'am.
Any doubt here?
No, ma'am.
Yeah. Now we'll go to NMOS part. NMOS part. What is Y node? And this is node G, right? This is node G. Okay. Y node is a combination of AEC. Y node is a combination of AEC. G node is a combination of BED. And between A and B, we have 3. Between A and B, where is A and B? We have 3. A and B, we have 3. Okay. So there is no connection is required at 3, right? It's no connection is required at 3. Okay. So always we'll follow merger diffusion. Okay. Always we follow merger diffusion. So it is 3. Next G, BED combination G. So where is BED combination in G means, see, this is ED combination, ED combination. So G, here only B. So G. So obviously BED combination will be G. Okay. Next. Then CD combination 4. CD combination 4. This is CD combination. Then what is Y? CAE is Y. CAE. So AE is Y. C is also Y. Okay. Then join this to ground, this also to ground. Okay. Right, this 3 no connection, only 3 is at only one place, so no connection is required. 4 is at only one place, so here 1 is at 2 places, so we connected. 2 is at 2 places, so we connected. So for 3, 4 no connection is required. G we connected. So Y, again we have Y here, right? So what we can do is we can join this Y. So here see, there is no crossing of same color anywhere, right? So we need a connection here. We need a connection here. We need a connection here. And this is our Y. See here, even though it is a 5 variable function, we did it with no additional electrical contact or Y. Got it? This is because of the Euler path. Do you get my point?
Yes, ma'am.
So this is how we draw the stick diagrams by using Euler path. So you see here, just for 2-input NOR gate itself, we have extra contacts and whites in our normal way, direct way. But if you use Euler path, even though it's a complicated function of 5 variable function, we could make it without any additional contacts, just with very minimal metal contacts. Do you understand this?
Yes, ma'am.
So this is how we draw the stick diagram. You please follow the same Euler path. And you please develop stick diagrams and show me in the next class. Even though I'm giving homeworks for you, you're not doing all the times, but this time you please do, so that in the next class you can ask me doubts, so that I'll clarify, so that you can draw the stick diagrams easily, because you have almost 20 marks weightage in both FAT and as well as in your CAT 2 for the stick diagrams and layout diagrams. Very, very important. So I'll give you some expressions. You please draw the Euler's path and develop the stick diagrams. Okay. So please note down 3-input NAND gate, 3-input NOR gate, 3-input NAND gate, 3-input NOR gate. Please note down. And you take this function 3-input NAND, 3-input NOR 2, then this function A plus BC into D whole bar, A plus BC into D whole bar, A plus BC into D whole bar, one function. And you can have A plus BC whole bar, A plus BC whole bar, A plus BC whole bar, and AB plus CD whole bar. AB plus CD whole bar. Better I write here. Better I write here. So homework. Please do it so that you can ask me questions. Okay. A plus BC whole bar. This is the fifth expression I gave.
Excuse me, ma'am.
A plus B, 1 minute, 1 minute. A plus BC into D whole bar. A plus. Just let me complete this. A plus BC into D whole. Please note down. I'll upload this. Whatever I have written, I'll upload. Yeah, tell me. Yes.
Ma'am, I was saying my next class started, so can I leave, please?
Yeah, you can leave it. You can leave it. Even I'm also leaving it.
Ma'am, actually, ma'am, I'm planning to give the recat, ma'am. The recat application is today and tomorrow, ma'am. So, ma'am,
Okay.
when will you upload the marks in Vita, ma'am? Because otherwise, I'm not able to register for the recat.
No, all I think it is. It's not we upload. Actually, they will pull up. I think already it is pulled up. You check.
Okay, ma'am. Sure.
We'll do it in Code Tantra, and I think they only will. The COE will pull it. I think you check it now. All maybe it is pulled all.
Yes, ma'am. Sure. Thank you, ma'am.
Okay. So I'm uploading this in VTop. See this for the Euler's path, how I have drawn it, and see the video, and please solve all these problems so that you can ask me some doubts, so that you can learn it, because you know that all of you, your performance in Cat 1 is poor. So see that your Cat 2 performance will be good. Okay, please try all this. Just I'll end the meeting. No, I'll upload this.
Able to see the quiz
And
one.
what
Ma'am?
was the class hour?
Hello. Yes, tell me.
We are not able to see the quiz 1 marks.
Actually, I have returned it. I'll check once again. Okay,
Ma'am, it has
Anish.
not reached us.
I will check it. I'll check it. Okay. So your Cat 1 performance, don't worry about the average. It's very, very less. It's very poor performance. So please respond to my works. Please do it. And try to get some marks in Cat 2. Try to score in Cat 2. Once it is, I'll tell you average in the next class. Okay. Because so far it is not pulled up in Cat 1. Now it may be pulled up. I'll tell you. It will be very less. Most of you
Thank you, ma'am.
didn't do well in Cat 1. I don't know. You are not working hard. Please try to get a good score in Cat. Okay. I'll end the meeting and I'll upload this.